G'day. We're looking at radians again today, and we're looking at the arc lengths and areas of sectors using radians. So it can be a little bit tricky. Sometimes if you've looked at the formula sheets in your textbook, they look kind of strange. I've never seen these kinds before. However, you have come across them. So what have you come across? Let's think about degrees for a second. We know that we could find the arc length in degrees. So let's just go back a little bit and think about, well, what is the arc length and what is the sector? So in this case here, if we're looking at this in terms of degrees, your sector is this entire piece of pie, where the curved part that we will highlight in red is your arc length. And if we look at the arc length here, we know it's giving us something in terms of the perimeter of part of a circle, okay? Or in this case, the circumference. So if we look at arc length in terms of degrees, we've got a formula for this already. And the formula here is the degree over 360 times 2 pi r. So that here is what our arc length is going to be. Well, we also know that your area of a sector is something similar. It's theta over 360 times pi r squared, which kind of makes sense. It's this degrees over this part of the circle out of all 360 and times it by your radius and pi. Because we looked in the last one that pi makes up that understanding of where unit circle comes from. However, that's in degrees. I did say right at the beginning that this here can relate to radians. And all you need to remember here is that 360 degrees is equivalent to 2 pi in radians. So if 360 degrees is the same as 2 pi in radians, I could just rewrite this here as over 2 pi times 2 pi r. So now I've got everything in terms of radians. However, we have a shorter way of writing it. And how do we get that formula? Well, the way we get that is if we look at this, we can have 2 pi cancelling out, 1 dividing 1 multiplying. So therefore, in radians, and we'll say radians from degrees, we end up just getting theta over r, which is what we would have as our, arc length, sorry. I'm thinking of area, is just the theta times r, because these two cancel out. So this is how we would work out arc length in radians. So it's basically the same process. Same thing will come when it comes to area. So it's just going to be this, our understanding over 2 pi times pi r squared. Again, if we do the same process, we can get rid of 1 pi. So we've got theta, and if we have a look at this in terms of, actually we'll get rid of the wrong one. Got rid of the 2 when I wanted the 2. I can get rid of the pi's. So if I get rid of the pi, what I've got left over here is I've got theta over 2 times r squared, which is equal to the area of a sector, which it can be rewritten sometimes as half theta r squared. So if we have that in terms of radians, you can do it both ways. It doesn't really matter. Here, this is what you've learnt in terms of degrees. This is what it looks like in terms of radians. But this here is a shorthand way of writing what these formulas represent. And I'll try to show you how we can cancel them down to get these types of formulas. Be good to try and commit these to memory because they will make life a little bit easier, but you could use this method here too. It's not going to make too much difference. So let's do a couple of examples and then we can see how it all works. So let's just get rid of all this information, leave that here. So we'll have arc length is equal to OL, or we could have it as 2 pi times 2 pi r, and then area is equal to, well, we'll do it this way, or degree over 2 pi times pi r squared. So we've got that information there. Let's leave that there so we can do a couple of examples. So let's find the, what do I want to find? Let's find the arc and arc length. Of the following. All right, so let's sketch it up. We're going to have 8 centimeters, 8 centimeters. What are we going to have in the middle here? Let's have 2.1 radians. All right, let's find out the arc length. So let's do it both ways just so you can see how it works. Arc length, where our arc length is going to be 2.1 over 2 pi times 2 times pi times 8. If we do that calculation correctly, we should get something like 16.8 centimeters. So the length of this here is 16.8 centimeters. If we did it the other way, well, this here just becomes 2.1 times 8, which again is 16.8 centimeters. So it really doesn't matter which method you're using, you're going to get that same answer. So this here was the arc length. If we look for the area, again, let's use 2.1 over 2 pi times 8 squared. If we work that answer out, we should get something like 67.2 centimeters squared. And alternatively, if we use the method that we had before, where we had half times 2.1 times 8 squared, we should also get 67.2 centimeters squared. So it doesn't really matter which method you're looking at. We can use either method for arc length or area. It's going to give you that same answer. Some people like it this way because it just relates them back to the degrees method. Other people like using the shorter method because it's just less work. Okay, whichever method you choose, try and stay consistent with it because it's going to help you remember those kind of calculations. Let's do one last example and then we'll move on. So we want to find the arc. So find the area of this sector. So if we have, let's write it up, we've got 0.8 here. I don't know what my radians are, but I know that my